In the last two lectures of this course, I will be presenting to you one very important aspect of intelligent behavior. A machine is considered to be really intelligent only when it can understand and interpret or speak, for that matter, natural language. Natural language is the language that we speak day to day ourselves. English, Hindi, Bengali, different languages that has evolved and through generations among the people through which they communicate is called natural language. And the capability to understand, interpret and communicate through natural language is a very important criteria of intelligent behavior. So, today I will be presenting to you an overview of natural language processing. Okay. So, the first question that we need to answer is, why should we at all study this? Why natural language processing is important? If we look from the practical side, then there are huge amounts of data available in the internet. For example, at least 2.5 billion pages are available. There is lot of information that is spread all over, which are in natural language. So, if a computer has to learn, it will have to utilize and understand such expressions which are available in the form of natural languages. And there are applications for processing large amounts of texts. We can see some of the typical applications here. Say there are so many text data available in the internet. Is it possible to classify these texts automatically into categories? For example, all the texts on electricity for school students. Can a computer program really understand the extent, the depth of the different texts and identify that, well, this is on electricity, and the contents of this text are suitable for some school children? Indexing and searching large texts. We need to search the texts, and also another very important application is automatic translation. We live in a multilingual world. So, if you consider the Indian scenario, it is not the fact that all the Indians, especially those who are deprived of good school education, that all of them understand English. So, in order that they can also benefit from some of the knowledge that is available in English, it needs to be translated to their local language, the language they understand. For India, it is even more important, because India is very much multilingual. Okay. Speech understanding is another important application, where, say for example, here is only one example given, understanding telephone conversations. But besides that, there can be so many other applications. If we could have a computer which could understand the speech of a person and say in Hindi, and that is automatically translated into text and is being recorded in the database of a computer, then it will be very much useful for not only for telephone conversations, but also for many other applications. Similarly, if a computer can understand a text that is written and speak it out, then for those who cannot speak, it would be a really great benefit, and this system is known as the text to speech system. Similarly, speech recognition, automatic speech recognition is a very important application. Nowadays, information extraction is gaining more and more importance, so that we can, one application can be that we extract useful information from the different resumes that we are getting. Automatic summarization of the texts. Suppose the entire content of a book, if it could be summarized in say 4 or 5 pages, then somebody could go to the internet and have a brisk review of the basic content of the book before he decides to purchase that book or read it. Nowadays, it is also done, but it is being done manually. If we had computers who could really understand natural language, then this thing could be done in an automated way. Question answering is also another very important application. Similar other applications are knowledge acquisition, acquiring knowledge from the experts, text generations, dialogues, and for all these applications it is needed, we require natural language processing expertise. Now, why do we call some languages to be natural language? These are the languages that we, as I said, that we use in our day to day life. It refers to the language spoken by the people naturally. For example, English, Japanese, Swahili, as opposed to, this is opposed to the artificial languages, or which we also call formal languages like C++, Java, etc. Now, these languages like C++, Java, etc. have got a very strict syntax. If I say Tom go to school, you will understand that I have made some grammatical mistake, that instead of saying Tom goes to school, I have said Tom go to school, but the meaning will be immediately clear to you. Or if I say gives me the glass of water, then also you will give me the glass of water, although the sentence that I have said is syntactically wrong. But such syntactically wrong statements will never be accepted in a formal language environment. If you just miss a semicolon in a C program, there will be parsing error. All right. So, the formal languages are strictly guided by the rules that are there in the grammar. In natural language also, we need the rules, we have got the grammar, but we are more free, and minor syntactic errors does not deter the communication of the meaning or the semantics. That is why we are interested in natural language processing, and since there is, it is in our communication, in natural language communication, we can take recourse to some ambiguous statements. Still, human beings can perceive it, understand it, and can act accordingly. Because of this flexibility, natural language processing is all the more difficult than formal languages. Now, natural language processing is required for applications that deal with natural language in some way or other. On the other hand, we often hear the term computational linguistics. Computational linguistics means carrying out the linguistic studies, studying the different features of a language using computers. There is a subtle difference between these two. This is more on the linguistic side than on natural language processing, but obviously they are very closely related. Okay. Now, if we continue our discussion on why natural language processing, let us look at some of these sentences. Okay. If you look at these sentences, they are not carrying any meaning to you at all. These are mere symbols which are not interpreted as yet. Now, when we feed such set of symbols to a computer, the computer will not understand anything. However, whatever data we feed to the computer, are symbols. Ultimately, they get converted into ASCII characters and the computer interprets that. However, in a C language, say whenever I type in the C program, what goes in is a set of string of ASCII characters, right. But in that case, we have got a program that a C compiler that is based on the strict grammar of the C language, which can interpret these strings of symbols. So, using that compiler based on that grammar, we have imparted to the computer the knowledge of the C language. Similarly, computers by itself lack the knowledge. So, they see the text in English the same way you have seen in the previous text, nothing but a bunch of symbols, and what is required is interpretation. However, people have no trouble understanding the language. We use common sense knowledge. See, for example, when this was shown, you said, hey, this is all garbage. Might be if this statement is from some tribal language, I do not know, might be, then they would have immediately understood that because of their common sense reasoning and because of their knowledge about that language. All right. So, similarly, if you show me a French statement and if I cannot recognize that, I will not be able to understand it. So, what is required is essentially common sense knowledge, reasoning capacity and experience. And computers have by itself no common sense knowledge and no reasoning capacity unless we teach them. Okay. Now, that is the overall scenario. So, that makes the natural language processing a little difficult. Now, if we look at the different areas of computer science research, you will see that computer science deals with databases, algorithms, networking, etc. And artificial intelligence, that is the course that we are working on now, has got several components in it like robotics, search, expert systems that we have seen, and natural language processing is one very important area of artificial intelligence. And why is natural language processing important? Because of many important applications like information retrieval, machine translation, language analysis. Now, when we carry out language analysis, that again includes understanding the syntax, the semantics of the language of any text that is written, as well as parsing. Just as we write compilers to parse C statements, similarly, we will see the difficulties that are inherently there for parsing natural language sentences. In this lecture and the next, it will not be possible to cover the vastness of the different algorithms that have been developed for natural language processing. The objective of this lecture is to introduce you to the problems of natural language processing and show you some of the approaches that have been adopted. And there is a vast open field lying ahead for those who are really interested in artificial intelligence and natural language processing to dig in more and see more of the subject. So, information retrieval, machine translation, understanding a language, all these things form a part of natural language processing. Now, when we look at natural language processing, there are different levels in which we can think of it. We can say that these are the different linguistic levels of analysis. Say we need to say speech is one level, that is the top level. If we can generate text from spoken speech, then all these utterances, the waveforms that we generate when we talk, have to be interpreted and captured and translated in the form of written text. That is one level. Even after that, we have got the written level. Okay. And in the written language, there are again different components. Phonology. What is phonology? Phonology deals with the sounds, letters, pronunciation, etc. Okay. Now, say when we say God or got, the meaning totally changes because of the last phoneme. Okay. Instead of pronouncing D, we are pronouncing T, and the entire meaning changes. The other thing is morphology, that is the structure of the words. Okay. Like child becomes children when we make it plural, all right, but book becomes books. So, based on this, we have to also understand that this morphological change, okay, morphology is the structure, the look, it has changed, all right, and with that change the meaning has also changed. Okay. So, that is also another level. Syntax. Now, syntax is essentially dealing with grammar, how these sequences are structured, and semantics deals with the meaning of the strings. When we go on, so at the best ultimate level of understanding, we have to understand the meaning of the strings. The syntax is telling us whether that those strings, the symbol strings, are well formed. We have to look into, we have to categorize the different components of those symbol strings when we do syntactic analysis. That also helps in understanding meaning, but with that we will understand some part of the meaning, but we need to dig in more, which we will see. And so, we could see that there are two levels, say at the abstract level, speech and written language. But again, inside the written language there are phonological aspects, morphological aspects, syntactic aspects, and semantics aspect, and there is a continuous interaction among all these levels. Next, we start discussing about the issues in syntax. Okay. Say we take a very funny statement, the dog ate my homework. Now, I am sure all of you will laugh at this sentence, the dog ate my homework. What does it mean? But syntax per se is not dealing with the meaning of the sentence. It is trying to see whether this sentence is syntactically or grammatically well formed. The meaning may be useless here. We can, but the syntax should allow me, if it is a correct syntax, then it should allow me to understand or answer questions like who did what, who ate, the dog ate. Okay. The dog ate what? The dog ate homework. Whose homework? My homework. So, all these you can see the components of this sentence have got a relationship among themselves, and that relationship is preserved in this sentence structure. So, strictly speaking, this sentence is syntactically correct. So, when we perform syntactic analysis, one very important part is to identify the parts of speech of a sentence. Parts of speech in school level, all of you were exposed to that whenever we talk about a sentence, then we talk about noun, verb, pronoun, adjective, adverb, etc. All these are known as part of speech, and they identify the relationship of or the role of that word in that particular sentence. For example, in this case the dog is noun, ate is verb, homework is a noun. Now, if I could write a program that would accept a sentence and will be able to label each component of the sentence with the proper part of speech, then that program is called, will be called a part of speech tagger, POS tagger, okay, part of speech tagging. Okay. So, in English, part of speech taggers exist with around 95% accuracy, but work is still going on where it can be improved. For Indian languages also nowadays we are working on part of speech tagging, and here also we are getting more than 90% accuracy by now. Also, the words may not always be should not always be looked at isolation, looked in isolation. We have to, we may, in order to understand the meaning, we may sometimes require to look at a group of words. For example, if there are 3 words mother-in-law, then we cannot just look at mother and try to find out its part of speech. Mother is a noun, in is a preposition, and law is another noun. But in order to understand, mother-in-law is actually mapping to another concept. Dog means something, that is an animal. Hot has got a different concept, but when in a sentence these 2 words are put side by side, when they are co-located, then these 2 should be looked upon together, because hot dog is a particular type of fast food. So, in order to understand the sentences, we have to understand the parts of speech, but also that is not the only thing. There are many other issues involved. One is collocation, and this identifying collocation is also known as chunking or local word grouping. Now, there are more issues in syntax. We would like to do, say we would like to do a shallow parsing, where we just like to find out which one is a subject, which one is a noun phrase, etc. So, what we can do is, the dog chased the bear. This is a sentence. Now, when this sentence is shallow parsed, we will first break up this sentence and identify that this the dog is the subject and chased the bear is the predicate. And then this subject is the basic structure of the subject. Subject is that it is a noun phrase, the dog, and predicate is a verb phrase, chase the bear. Now, shallow parsing is often adopted when we try to understand a new language, and now the works are on, as you will see that in order to have good, quick and good parsing, we need to have one very important approach is again a statistical approach, where we need a lot of training data to understand that given a word, what is its probability of being a noun, what is its probability of becoming of mapping it to a particular concept. All right. Now, this picture may not be very clear to you, but I will be working it out. Here is again an example of parsing of a sentence, say John loves Mary. So, since this picture is not clear, I will be working out my sentence with which we start is John loves Mary. Now, when we parse this sentence, first thing is I will break it up as a noun phrase. The parser will break it up as a noun phrase and a verb phrase. And this noun phrase is this part, John, and the verb phrase is loves Mary. And this noun phrase is further broken down as a noun, and that noun is John. So, that is coming to the terminal symbol John, and the verb phrase can be further broken down into the verb and the noun phrase, and this verb is loves and the noun phrase is the noun which is Mary. All right. So, this is the full parse tree. So, this is a terminal symbol, this is a terminal symbol and this is a terminal symbol. All right. So, this is a parse tree. Now, one interesting thing, just look at this loves. We know the meaning of love as a verb. Now, an intelligent system should be able to understand that when it is loves, it is essentially a morphological change of the same verb love, and because it is a third person singular number, that is why this addition of that s has come and these two are basically equivalent. All right. Now, I will just give you another example of similar parts. Say the dog or the boy went to school. Now, how do we parse it? Again, it will be broken down to the noun phrase. Which is the noun phrase? This the boy, and which will be a verb phrase, which will be this went to school. And this the boy will be further can be broken down as a determiner or article and a noun. And this determiner is the, which is a terminal, and the noun is boy. The verb phrase can be broken down to a verb which is went, and it will have another noun phrase. What is this noun phrase? This to school. All right. And this noun phrase can be further broken down as a prepositional phrase and a noun, and this noun is a terminal school, and this prepositional phrase has got a preposition to. So, this is how we parse it, but it is still there are many issues, because for example, again let us see went. What is this went? The went is the same thing as go in the past tense. That has to be known, that knowledge is required in order to understand this sentence. But by this parsing, what have we got? We have got the, we have been able to understand the role of each of these words, that okay, the boy is a noun phrase. So, that is the subject of this sentence. Okay. This is the verb, went is the verb, etc. So, parsing is one. So, this helps in figuring out automatically questions like who did what and when. If we ask John loves Mary, then if we ask the question who loves Mary, from this parsing we can straightway come to the subject and say well, John loves Mary. There are more issues in syntax. One interesting thing is, this is a very interesting example, Aphora resolution. See, we always have got this sort of sentences. The dog entered my room, it scared me. Now, when you look at this it, which is a pronoun, now to which noun does this pronoun? All of we know that a pronoun stands for a noun. Now, in this case, a system must, if I ask the question who scared you or who scared me, the system should not answer it, the system should answer the dog. So, the computer must understand, the system must understand that this pronoun is actually related to this noun, the dog. Okay. So, this is this sort of problems are called the anaphora, and when the second one is a more interesting problem. I saw the man in the park with a telescope. See, there is a lot of problem here. I saw the man in the park with a telescope. I can interpret it in different ways, that I could see the man because I had a telescope. I saw with a telescope, and what did I see? I saw the man in the park. Or this could be related to the man, that I saw the man with a telescope in the park. A man was carrying the telescope. Or the other thing is, I saw the man in the park which had a telescope. Okay? These are three possibilities. Now, which one of these is really meant? Now, even for us, there are two. We can understand that in a park, it is very improbable to have a park with a telescope. But of course, I mean, it is possible that you can have in a special park for some astronomic fair, you can put in a telescope. That is also possible. But probably I saw the man with a telescope the man in the park. So, I used a telescope to see the man, or the other possibility is I saw the man who was carrying a telescope. So, you see there is a lot of scope, the scope of lot of ambiguities here. Now, similarly, there are several issues in the semantics. Now, the earlier one was syntax, okay. But even if we resolve some parts of the syntax, there are several issues in semantics. For example, say semantics means understanding the meaning of the sentence. How do we understand the meaning of the sentence? Say the same word plant can mean an industrial plant, a chemical plant, electrical plant, whatever. Plant is also a living organism. So, often the words that we use are ambiguous. Say, what is the importance of semantics? Unless we really understand the meaning, then we will not be able to translate them. There will be wrong translations. If we try to carry out information retrieval, there will be wrong information that we will be extracting, and if we cannot do anaphora resolution properly, then we will also have wrong reference. Now, how do we learn the meaning of the words? One thing is that from the dictionaries, we can have that plants, plant, works, industrial plant, all these can be put in as buildings for carrying on industrial labor. They built a large plant to manufacture automobiles. So, these sort of sentences or glosses that we have will map to this, but again there is an entry in the dictionary: plant, flora, plant life, a living organism lacking power of locomotion is a plant. Now, when we say a sentence, we state a sentence, they are producing about 1000 automobiles in the new plant. Then which one of these meanings would my system choose? I have to resolve that, and I have to really understand that since I am talking of automobiles, and automobiles require some industrial labor and a large plant, so obviously this new plant means an industrial plant where cars are being manufactured. I will obviously not interpret it as a plant in the form of a small tree. Again, for this sentence, the sea flora consists in 1000 different plant species. Now, we have to understand that this plant species is not the industrial plant, but this sense of the plant. Now, what happens to this? The plant was close to the farm of animals. The plant, it may be an industrial plant, or I am talking of a particular plant. So, you see gradually the context is also becoming important. Merely the role, when I do the parsing, merely the role of the sentence is not enough, role of the components of the sentence, the part of speech is not enough. So, what to do? How do you really understand meaning? There are several issues which are involved and it is rather complex. One approach, as I said, which is very popular nowadays, is the statistical approach. There we start with a set of examples which are annotated. That means, in a sentence like this, they are producing about 1000 automobiles in the new plant. In this sentence, I manually annotate it and they say the meaning of this plant is actually industrial plant, first meaning, not the second. I annotate many such sentences, all right, and a system may be designed using a number of tools like the hidden Markov model and other technology, which we will not cover in this course. There are technology available using which a system can learn the probability of a meaning given a particular structure of a sentence. Okay. So, suppose we take 100 examples containing the word plant, which are previously tagged by a human with the meanings, then we train a learning algorithm. Okay. There are several learning algorithms including the neural net algorithms. There are different classification algorithms, there are Markov models, hidden Markov model algorithms, there are different approaches. So, we will train a learning algorithm and using that algorithm, when new sentences are fed, we expect that this algorithm will try to find the closest meaning statistically. Right now, the precision in this is a little more than 80% and a lot of research is going on in this area. And how to choose a learning algorithm is an issue. Now, one thing you must realize that natural language, this sort of approaches require the human tagging. So, you cannot have any soft path to success. There is the necessity of putting in the labor of tagging them properly, at least a small set on which we can later on bootstrap, but we will have to make a small set properly annotated on which we can run our statistical learning algorithms. So, another issue is how to obtain the 100 tagged examples. Okay. Now, so we were talking of learning using learning algorithms that will learn the semantics. Now, what are the issues in learning the semantics? We can assume a large amount of annotated data for training, all right, and usually say we train our algorithm and then we take a new text which is not annotated, which a set of new texts which will be used for the test. So, our approach is learn from the previous experience, that is a training, to classify the new data. The test data will be annotated automatically based on whatever our system has learned from the corpus of already annotated data. All right. So, there are different algorithms for that, like decision trees, memory based learning, neural networks, which some of these have been covered in this course when machine learning was being discussed. Besides, there are several issues in information extraction. The purpose of this lecture, as I said, is to provide you a glimpse of the different aspects of natural language processing, which are very useful now in the present day technology. Say we are given a sentence, there was a group of about 8 to 9 people close to the entrance on highway 75. Now, from this a computer program should be able to extract the information like the answer to the questions who, 8 to 9 people, where, on highway 75. All right. So, this sort of answers should be extracted from this sentence, where you see it is not just a very straightaway case where close to the entrance on highway 75. Okay. Extract the information, and also it is required often to detect new patterns. There are issues in information retrieval as well. From the lot of from the huge bank of information that we have in the internet, how do we extract out the information that is relevant? That is an issue. So, a general model of information retrieval is that we start with a huge collection of texts and we have got a query, and our task is to find the documents that are relevant to the given query. We have to find out the documents which are relevant to the given query. There are different measures to really compute which are relevant. Okay. For example, there are texts on cricket, all right, and I want to find out the texts only which talk about Sachin Tendulkar. Then one measure, because my query in that case is Sachin Tendulkar. In that case, out of all these texts that are there, I have to evaluate or rank all these texts based on the keyword of my search, which is Sachin Tendulkar. A very common sense approach would be the texts which have got larger number of occurrences of the keyword Sachin Tendulkar will be more relevant. Maybe there is a text in which a lot of things about cricket have been said and Sachin Tendulkar has been mentioned only twice, but it is talking about many other things. So, that particular text will not be that relevant for me. So, that is one approach of a very, it is a too simplistic approach, that we select the keyword and based on that we find out which one is relevant. So, we usually find out the documents through creating an index like the index in a book, and application of such information retrieval you will find in most of the search engines like Google, Yahoo, Alta Vista and everything. The main issues in information retrieval are we have to index the meaning, because as we have seen one word can have multiple meanings. In that case, which meaning should I assume this word to refer to? For example, if I say I went to the bank to see the sunset. Bank may be the typical bank where we keep money, all right, and bank can be a river bank also. So, this is one of the ambiguities which is known as polysemy. Polysemy means when a particular word can have multiple meanings. Consider the word bank. You can see that we will have different meanings, like bank can be say cache of money, all right, like the things that we have, State Bank of India, all right. Another thing can be a river bank. Another thing can be bank can mean depend. For example, I banked on him, all right. I banked on him. Now, when I am given the sentence, I went to the bank to observe sunset, then this is my sentence which I am trying to understand, which the machine is trying to understand. Now, you can see that just by syntactic analysis through the normal parsing, I will find out that this bank is basically a noun, whereas the meaning of this meaning depend is a verb, right. So, this meaning is not applicable. So, you see here that by syntactic analysis itself, without going into any semantic analysis, we have been able to eliminate some of the meanings which are not applicable. Okay. So, let me eliminate this. I eliminate this part. Still, I am left with a problem of two possible meanings, that this bank, both of them are noun, this is noun, this is also noun, and this part of speech is also noun. Now, which of these meanings should I take? Okay. Now, here I need some more knowledge in order to solve this problem. What sort of knowledge is required? That knowledge will be from the context, okay, that sunset is usually watched, observed near a river or a sea. So, the probability of this bank being a river bank is higher in this context, because this bank is associated with this phrase to observe sunset. All right. If the sentence was, I went to the bank to withdraw money, then obviously, if this sentence was not there and instead I had written I went to the bank to withdraw money, in that case this bank would have related to this meaning because of the association. Now, one artificial intelligence, one knowledge representation structure that we have already learnt comes in very handy over here, that is the semantic net. The semantic net represents the meaning. So, if in our knowledge base we have got the semantic net, in that case we can handle this sort of situations. For example, I can have say bank, I hope you remember semantic net, you have not forgotten that, is a say institution which stores money. Bank say is close to river. Bank is visited by people. Watch sunset. Say I have got this sort of structure. Now, I went to the bank to withdraw money. When I try to understand the meaning of this sentence, I will traverse, I can utilize this semantic structure and I will find that there is a better relevance, because it is leading me to the concept money, which is already over here, and so I will take that meaning of bank in order to interpret the sentence. Okay. So, this sort of knowledge is required for retrieving information from the web, or there are other issues like this same thing can be very useful for question answering. Say, what is the height of Mount Everest? 11,000 feet. Now, the current state of the art of information retrieval accurately, where the precision and recall, these are two very important measures, is around 40 to 50%. There is a lot of scope of research and lot of scope of work in this area. We improve the precision with the use of more common sense knowledge, and often we capture this common sense knowledge in the form of knowledge representation. Okay. There are other issues like cross language information retrieval. That means, we want to find the information across languages. For example, what is the minimum age requirement for car rental in Italy? Now, with this query, when I search the documents that are available in the web, it is not sufficient to restrict myself to the documents which are written in English only, because since I want to get the information about some law in Italy, there may be some Italian documents written in the Italian language which may come in handy for me, but I understand English. So, and my query has been given in English. Therefore, what is needed is that I will accept the query in English, and I will go to the documents, search documents which are English documents. I will also search Italian documents. Now, the query is in English. So, I need to have some sort of translation at this point, or I must use some other technique. So, from here I will be getting some documents which are Italian documents, and from here I will be getting some English documents. Now, my answer should be this English documents, and these Italian documents will require to be translated. MT means machine translation, and ultimately I want to have the answers in English, because I know only English. This is cross language information retrieval. Okay. So, we will have to convert this to some Italian texts in order to do this sort of translation. Now, just to complete this lecture, I will mention about some of the issues in machine translations. There are text to text machine translations, that is, given say English, I want to get Hindi, or given Hindi, I want to get that document in English, or speech to speech machine translation. That is the ultimate dream that all of us cherish, especially in a country like India. Say, I say speech to speech, that is the ideal, but we are still quite far from reaching the desired goal here. Say here I accept some Hindi speech, all right, and that Hindi speech is recognized by automatic speech recognizer ASR, and from there I get Hindi text, and that Hindi text can be translated by some machine translation to English, and then using some text to speech system TTS, English or maybe other Indian languages like say Bengali, and there is a text to speech system TTS stands for text to speech, will convert will speak out this English or the Bengali sentence to another person. So, I am getting Bengali speech or English speech. So, you just try to imagine if this were possible, in that case a person speaking Hindi would be able to communicate with a person speaking English and vice versa from English speech. So, when he speaks English, then it goes to an English ASR and I get a Hindi, and that Hindi is again converted to the Hindi TTS, and that can be spoken out as Hindi speech. You see the advantage of this. And so, speech to speech, and as you have seen that in this case we also needed not only we needed automatic speech recognition, we needed text to speech, we needed machine translation. All these are in the domain of natural language processing and are present day challenges. So, in the next lecture we will see we will concentrate on natural language understanding, how some of the approaches of how natural language can be understood. Thank you.